Okay, in this video we're going to look at solving log equations. Okay, so first one we're going to look at is one like this. So solving log base 2 of x equals 2 log base 2 of 5. Okay, so to solve that we need to isolate what x is. Well, we can use our power rule and bring the 2 up here. Okay, so using our power rule, bring the 2 up there, and then we get log base 2 of x equals log base 2 of 5 squared. Okay, and at that point, because it's log base 2 on both sides, we can just eliminate that, so the insides must be equal. So x equals 5 squared, x equals 25. Okay, so that's that one. Now for this one over here, log base x of 6 equals negative 1/2. So we're actually solving for the base in this one. Okay, so if that's true, then we can rewrite this with x to the negative 1/2 must equal 6. Okay, so rewriting this as an exponential expression, it's x to the negative 1/2 equals 6. Okay, now what to the negative 1/2 equals 6? Well, we can rearrange this a little bit. We can do these both sides to the power 2. That would get rid of the half, but you still have the negative 1. So instead, we do both sides to the exponent negative 2. So negative 2 times negative 1/2 gives you 1. Okay, so a power of a power means you multiply those. So when you multiply these, you're going to get negative 1 on this side. Or positive 1, sorry. So x to the 1. And on this side, you're going to have 6 to the negative 2. And 6 to the negative 2, well, that just equals 1 over 6 to the 2. Okay? And 1 over 6 to the 2 is just 1 over 36. So that's how we solve those two simpler log equations. Now, what about something like this? Okay? So 3 log base 4 of x minus log base 4 of 2 equals 2. Well, in this one, we can use our log laws to reduce that down to 1 log. Okay? So this 3 comes up, so it's x cubed instead of 3 log base 4 of x. Okay? And then we can do our subtraction law. So we've got log base 4 of x cubed over 2. That's what happens when we subtract. And we get that equal to 2. And now we can get rid of the base 4 here by putting on the other side for an exponent. Okay, so we've got x cubed over 2 equals 4 to the 2. That's how we undo the log. We use the exponential. And so 4 to the 2 equals 16. So x cubed equals 16. So x cubed over 2 equals 16. And then x cubed equals 32. And now we could cube root, and we get x equals the cube root of 32 as an exact value, or 3.17 as an approximate value. Okay, another way of doing this, from this point here, we can just bring the log base 4 of 2 over to the other side. Okay, and then turn this 2 equals log base 4 of 16. Okay, so we can turn a whole number into a log. Okay, so log base 4 of 16, well, 4 to the what equals 16 is what you ask, and that equals 2, so that's how you can convert that there. So basically you take 4, you square it, and you put it in here, and it converts it to a log. Okay, so you might want to take a minute to check that out, make sure you understand that. So now we've got an addition here. We can bring it in as multiplication. 2 times 16 is 32. So it's log base 4 on both sides. We can get rid of that now, and just x cubed equals 32, and x equals cube root 32, which is approximately 3.17. Okay, so these are two different ways of getting to the same point. Now, if we want to solve something like this, log base 2 of x plus log base 2 of 3 equals 3. Okay. So we can bring the left side together because it's a sum, so that turns into a product. And we can bring this 2 over here, becomes an exponent, so 3x equals 2 to the 3, so 3x, so x equals 2 to the 3 over 3, which is just 8 over 3. Okay. And some more log equations here. Okay, so they get a little bit harder now. So this one, log base 6 of x plus log base 6 of x minus 5 equals 2. So now we have x in more than one place. Okay. Well, this is a sum. The bases are the same, so we can bring that together as multiplication. Okay. And now we can get rid of the log base 6 by using 6 as the base for an exponent over here. We've got x times x minus 5 equals 6 squared. Okay. X times x minus 5 equals 36. So now we've got a quadratic equation. We need to expand it all, simplify it, and bring it all over to one side so we could possibly factor it. Okay. So we expand the left side, bring the 36 over. Okay, so we have it all to one side. We have a quadratic equation now. So you can factor it or use a quadratic formula, whatever you wish. You're going to get down to this, and that means x equals 9 and negative 4. Okay. Now, because this is a log equation, I'm not quite sure how these work, as well as polynomials, so we do have to do a check. We've got to make sure. So let's check x equal to 9 on this. So we're going to do a left side. Okay, so check x equal to 9. So the left side is log base 6 of 9 plus log base 6 of 9 minus 5. Okay, so that's the left side, log base 6 of x plus log base 6 of x minus 5. Now, simplify that. Log base 6 of 9 plus log base 6 of 4. Kind of hard to do on their own. So we're going to bring it together, multiply it. So 9 times 4 is 36. And log base 6 of 36 is 2, which is the right side. Okay? The right side of that equation was 2. So that means that x equal to 9 is a solution. Now, we're looking at the right side, or the other solution. So x equals negative 4. For this one, if we go to sub this negative 4 in, on the left side, we get log base 6 of negative 4 plus log base 6 of negative 4 minus 5. Okay, again, we're subbing into the left side here for x. And when we go to evaluate this, well, you can't log a negative. Okay, because here's the log function, log base 4 of x. Negative 4 is over here. If you go up or down from there, you never hit the function because the y-axis is an asymptote. Okay, so the log function never goes to the negative, so you cannot take the log of a negative. Okay, so this is not possible, which means negative 4 is not a solution to this, and x equals 9 is the only answer. Okay. Now you could have cubics in there too. You could have the sum of 3 things, and then you multiply them all together. You could have a cubic. You could have rationals, because it could be subtracted. Okay, you could be solving rational polynomial equations again, and then you got to check. Okay, so all the polynomial and rational function stuff can come back through this. Okay, so that's it for log equations.